Hi guys, welcome to another exciting video on Java. We have learned a few topics from the first unit in the last video, guys. We have learned about something called as method overriding, method binding and exceptions. Today we're going to continue with some more topics on first unit. We're going to revise a few topics on something called as encapsulations, inheritance and polymorphism. So stay tuned guys, I will see you on the other side. So today I'm going to talk about the first topic, that is your encapsulation in Java, how encapsulation works in Java, how important it is, and how the security of your code will be increased when we use something called as encapsulation, how it works we will see. Next we're going to look at something called as inheritance. Remember, this inheritance is a very, very important concept, one of the pillars of your object-oriented programming, how inheritance works, and how you have different types of inheritance. There is one inheritance not there in this, which was there in C++. So we're going to talk about all those things in this particular topic. Next, we're going to talk about something called as polymorphism. There are mainly two types of polymorphism that we're going to talk about. What is polymorphism? We'll discuss about it a little later in this video, guys, and we will end with this particular topic. Alright, so we'll start off with the first topic today, guys, that is encapsulation. So this is one of the most important first principle, OOP principle, that is we have to talk about, right? It's object-oriented principle, programming principle, right? So remember, this is called as encapsulation. So when we talk about encapsulation, encapsulation basically means that it binds the data and code together. That means that, remember, whenever you, for example, I will give you a simple example, guys. You go to an ATM, right? You go to the ATM, you put your card inside the ATM, right? Either a credit card or a debit card, whatever card you have. Next, you put the PIN number, then you choose the amount. For example, if you want to withdraw some money, you can choose a savings or a current account. And after that, you basically put the amount you want to withdraw and click on OK. Now, when you click on OK, there are so many things that are happening in the background which you actually do not know. Right? Basically, when you're trying to withdraw some amount from your account, the money is getting debited from your either your savings or current account, right? And basically that information needs to be reflected in the database. So there is a program that is working in the background on debiting the amount from your account and updating itself in the database, which you do not really care and know about whenever you go to any ATM. Similarly, when you drive a car, when you put a gear, for example, you put the first gear and then you go to the second gear, do you really care about how the gear system works, the transmission works? No. Normally we just sit in the car, we turn on the key and we start driving. So the implementation of things we do not really know. For example, you go to, as you drive a car, you do not know how the car is being driven. You just use a pedal, right, to accelerate, and a stop pedal to stop it, and you have a steering wheel to move around. Now, how the engine works, what is happening inside the engine, how does the transmission works, all these things we do not really know. The implementation part is completely hidden from the user who is using that particular car. So remember, the same concept applies for encapsulation. So when we talk about encapsulation, remember, we are trying to add some security to your Java code. Normally, a class which basically follows this encapsulation principle will have variables declared as private. Okay, all the variables will be declared as private, and the other classes which try to inherit from that class, okay, they cannot inherit the private variables. So in that case, what happens is, the class which contains all those private variables, okay, will have something called as a get method and a set method. Using the get methods and set methods, I can access those variables which are there in that particular class. So basically what happens here is, that particular user who is using this particular code will not know how the implementation of that code is happening, but he is able to enter the data and use that particular application. So whatever application is there in front of him, he can easily use that application. But what is happening in the background of that application, he will not know and he doesn't really care about. So if a hacker also tries to hack into your code, he will not be able to hack it so easily because of this concept that we are using, that is your encapsulation concept. He will not have access to the implementation part of your code, right? He can put the data, he can manipulate the data, but the implementation part is completely hidden. So a simple example I have already given you, right? So for example, you have, in this particular example on the slide, you can see there, he has given an example of transmission. So that's a simple example of how an encapsulation works in Java program, guys. You are basically hiding the implementation from the user. The user does not know how that particular thing is being implemented, okay, but he knows how to enter the data and use it. So that is how encapsulation works in Java, guys. And next we will go to another topic, guys. All right, so you can see here in this particular diagram, this is how your encapsulation actually works or looks like. Within a class, you have your data members and methods. They're all, binded together, right? And normally all the variables will be declared as private, and there will be get methods and set methods which will be used for manipulating the data, right? Only those get methods and set methods will have access to those private variables within that class. The other classes which are inheriting from this class, where your private variables are declared, the other classes which are inheriting will not have access to it, right? So that is the main concept of encapsulation. So we will move on to the next topic. We are going to talk about something called as inheritance, guys. So the next topic we want to talk about is inheritance. So in this case, remember, when we talk about inheritance, it's a very general word you would have come across in a daily life. So basically, we normally say something called as you have inherited the properties from your parents, you have inherited some properties from your grandfather. So inheritance basically means that whatever was there, whatever, for example, properties that your father or grandfather owned, all that property is your own, right? Once once your family is not around, right, you are the sole owner of that particular property. You have inherited the property. You have not bought the property, but you have inherited the property. So basically, whatever land was there with your grandfather will be there with you also. So that is how, that is a simple example of what inheritance is. Similar concept that we use in our programming also. So basically, when we talk about Java program, you have so many different classes, right? So when we talk about different classes, one class can inherit the properties from another class, right? You can see on the screen an example there, guys. Okay, first we'll see the definition. Inheritance is the process by which one object acquires the properties of another object, right? So in example there you can see here, we have an animal class under which we have reptile and mammals, right? Reptile is another class or an object which is inheriting from animal class. Mammal is another object or a class which is inheriting from animal class, right? And so on. You can see that there are so many child classes under your mammal class, and there is only one child class called reptile, and the topmost parent class for all the classes is animal class. So whatever is defined in your animal class is inherited automatically in your mammal as well as reptile classes. I will explain you with a small example now, guys. So you can see here, guys, whenever we talk about inheritance in Java, you can see there are different types of inheritance we can have. So when we talk about inheritance, there are mainly 4 types of inheritance that are there in your Java also, guys. Just like in C++, we had 5 inheritances. In Java, we have mainly 4 inheritances for classes, right? So when we talk about inheritances, first is your single inheritance, or it is also called as simple inheritance. Next, we have multi-level inheritance. Next, hierarchical inheritance. And we have another thing called as hybrid inheritance. It is not there in this diagram, but remember one more we have is hybrid inheritance. The last one that you see there, multiple inheritance, is not supported in Java, guys. Multiple inheritance is not supported for classes in Java. Multiple inheritance is supported only for interfaces in Java. Okay, so remember, mainly we have 4 inheritance concepts in Java: single inheritance, multi-level inheritance, hierarchical inheritance, and finally we have hybrid inheritance. Now what do you mean by hybrid inheritance? Hybrid inheritance is nothing but a combination of the any of those first three that we talked about, right? So initially we will see what is single inheritance. You can see in the diagram, a single inheritance is nothing but you have 2 classes, a class A and a class B. A class B is trying to inherit the properties of class A. On the right hand side of that particular diagram, you can see public class A, and then we have public class B extends A. Now class B is a child class which is inheriting the properties of the parent class called as A. The way it does is using the keyword called extends. So public class B extends A. That means all the properties which are defined, the methods, variables which are defined in your class A will be available in your class B also. The copy which is there in class A, the same copy will be available for class B. Next, we have something called as multi-level inheritance. When you talk about multi-level inheritance, you can see that there are three classes there. We have normally a class A, B and C. Okay, so class A is the topmost class that we have in inheritance in this particular case, and then we have another class called as B, which is extending from class A, and then class C is extending from class B. So remember, B is a child class of class A, class C is a child class of class B, right? Or in another words, class B is the parent for class C, class A is the parent for class B. Okay, and for class C, class A is the grandparent, right? So basically in this case you can see that whenever there is a copy, some methods or data variables are defined in class A, the same copy will be available in class B as well as in class C. Okay, so this is what multi-level inheritance looks like. Next, we have something called as hierarchical inheritance. Now this hierarchical inheritance, we have only one parent class and then there are two child classes inheriting from the same parent. In that case, that is called as hierarchical inheritance. Public class A, you can see there, public class A, then you have public class B extends A, public class C extends A. There are two child classes B and C extending from class A. So that is an example of hierarchical inheritance. Now there is the last one is called as multiple inheritance, which is not there for classes in Java. The reason is because remember you are having two classes there, class A and class B, and only class C is the one which is the child class which is trying to inherit from class A as well as class B. Now if there are functions, same function names defined in class A and class B, there is a problem, right? We do not know if class C is trying to access or inheriting the function that is defined in class A or inheriting the function that is defined in class B. Because of this ambiguity, this multiple inheritance concept is not there for classes in Java, but it is there for something called as interfaces. We will see that in some other video. So please remember, the last one we have is hybrid inheritance. So combination of single inheritance, multi-level inheritance and hierarchical inheritance, any of those three or two of those three, combination of those are nothing but called as hybrid inheritance. Next, we will finally look at something called as polymorphism, guys. So here we are going to look at something called as polymorphism. Now polymorphism, basically most of you would have heard already and you should know about this word. Poly means many, morph means forms. Many forms is nothing but polymorphism. So basically this polymorphism concept is a very important OOP concept in Java also, guys. Basically it means that we have something called as method overriding, method overloading concepts in Java, which basically use this concept called as polymorphism. That means a simple example I'll give you. I just now told you something called as method overloading. So within a class you can have two same methods. You can have methods with the same name but different parameters. Within the same class I can have two methods with different parameters. So in that case, that function which is having same name with different parameters is called as method overloading. You are overloading the method with different parameters. That is a concept of polymorphism, and it is a concept called as a static binding a static binding concept, right? So basically the binding happens at the compile time itself, right? So method overloading is a concept of static binding concept, right? Next we have another example called as method overriding. Now when we talk about method overriding, I have already discussed in the previous video, guys. Method overriding basically means that you have two classes, parent and a child class. In the parent class you have a method, in the child class you have a method. Both the method names are same. When both the method names are same in two different classes, a parent and a child, then it is a concept of method overriding. So basically we say that the class which is having, the function which is having the same name in the child class is overriding the function with the same name in the parent class, right? So this is called as runtime polymorphism, right? Or it is called as late binding. It is also called as late binding, or it is runtime polymorphism. And the one that I talked about, method overloading, is also called as compile time polymorphism. So these are the two main categories when we talk about polymorphism. So basically what we are saying is two methods with the same name with different parameters is called as method overloading. Two methods in two different classes with the same name with the same parameters is called as method overriding. So method overriding is a concept of runtime polymorphism. Method overloading is a concept of compile time polymorphism. So this is what polymorphism basically means. So on the slide you can see there a simple example would be, consider a stack. Okay, you might have a program that requires 3 types of stacks, one stack for maybe integer, one for floating, one for string, and so on. So many different forms of stack you might require, right? So this is a simple example of what a stack means, polymorphism basically means, guys. So this is what, these are the 2 types of polymorphism. Normally we talk about something called as compile time polymorphism and runtime polymorphism. In a diagram I have shown you here, we have something called as a method overloading, which is nothing but your static or early binding, and your runtime polymorphism is nothing but your method overriding, which is a dynamic or late binding. I hope you remember, binding is basically nothing but binding the method called with the function's body's address is nothing but binding, right? So there are 2 types of binding, that is static or early binding and dynamic or late binding. So we will end the video at this particular topic. I will come back with another video with some more topics in first unit, guys. Thank you. See you soon. Please share this video to as many people as you can, and like and subscribe. Thank you, guys.